So I didn't want to say one on the graph.
All right, work with graphs of equations. Hopefully you're getting a little more in tune to them. See our base equation that we have dealt with throughout all the problems we have with respect to graphics. We have y equals vertical phase shift plus or minus a sine or cosine b theta minus horizontal phase shift. Where, once again, your amplitude is equal to the absolute value of a. That's your distance from your neutral axis to your peaks or distance from your neutral axis to your valleys. Period. It's calculated by 360 divided by b. It's the number of degrees in a cycle. Okay, a cycle is a portion of the graph to the next portion of the graph where it starts to repeat itself. We have vertical phase shift, which is a vertical slide of the graph up and down. This gives us our prime axis. This is where we draw on our prime axis. And then we have our horizontal phase shift, which is our slide side to side. This gives us our theta start value. The value that we start our value of theta with respect to do a start at what degree measure. We also talked about the y-intercept. We substitute 0 in for theta, and we solve for our y value to the point where we cross the y-axis. When we're talking about a sine curve, we start on the prime axis. We start on the prime axis. If it's a positive sine curve, we start on the prime axis. We climb up, back down, back up again. If it's a negative sine curve, we start on the prime axis. We go down, up, and then back down again. These are things that we should remember as we're going through the graphs. Our visuals, which will be embedded on brain, is what does a sine curve or a cosine curve look like? Our cosine curve will start at a peak or a valley. Start at a peak or a valley. When we have a positive cosine curve, we'll start at a peak, we'll go down and back up again. When we have a negative cosine curve, we start at our valley. We go up and then back down again. For what we have dealt with or what we've talked about for the past 3 or 4 days, this is a combination of everything put together. So as you go through the problems, this is what you should be remembering and looking at in regards to trying to figure out how do I deal with the graphs. Now, the one thing that I will not do is something that the book does, because they try to give you different types of problems to make you adjust. They give you some funky poodle types of horizontal phase shifts. I'm not going to give you a horizontal phase shift of 6 or 17. Okay, if you did problem number 4, they gave you a horizontal phase shift of 6 and a period of 36. I'm sorry, 72. I'm not going to give you that. In problem number 7, they give you a horizontal phase shift of 17 and a period of 360. I will keep it for the most part like you would see in problem number 3, problem number 6, problem number 5. I won't give you a 41. I will keep it in regards to horizontal phase shifts as multiples of 30, maybe 45 in there. I'll give you that as your horizontal phase shift. The periods, I will keep it as multiples of 90 or 30 or 60. I'm not going to give you really weird periods or horizontal phase shifts. I'll keep it simple. I don't need to complicate the problem and make it more difficult by adding that kind of stuff in there. I'm able to grade and evaluate what you're doing with what I'm doing in regards to the types of problems. Questions, anything you would like me to go through? Like problem number 6, you have an amplitude of 3,000 and a vertical phase shift of 1,000. Now so I'm not going to give you the big numbers, but that would be easy to deal with. Just count them by 1,000, 1,000, 2,000, 3,000, 4,000. Anything you'd like me to go through? Once again, it's important that you keep up with the material. You check the answers that you do have, and once again, I keep it all in perspective because I'm not going to give you some weird problems that you have to work with. Weird numbers. All right, today, if you still do have questions, as we continue to go through the work today, hopefully little questions that you may arise in regards to your struggles. Hopefully, as we go through these things, will be answered. Because today, what we're going to do is put the process into reverse. I'm going to give you the graph. And we need to come up with the equation given the graph. But we still have our base equation that we have to worry about. Y equals vertical phase shift plus or minus A sine cosine B theta minus horizontal phase shift. We have that base equation that we continue to refer back to. What we now need to do is, by looking and inspection of the graph, we need to come up with those 4 values. We need to come up with the amplitude, period, vertical, horizontal phase shift to be able to substitute into the equation. Well, the first thing that we should take a look at is the first thing we took a look at when we were graphing. Where would we draw in our vertical phase shift? Well, let's get some numbers down here. I didn't put numbers on the y-axis. Let's see. We'll go -1, 1, 2, 3, 4, 5, and 6. Where would we draw in a prime axis? We have peaks at the value of 5. We have valleys at the value of -1. So where would we have to draw in our prime axis? Well, let's think about what's the prime axis do. Well, that is the axis that we go up and we go down from to be able to get our graph down. So where would we draw in a prime axis? Connor? What do you think? I have a value of 5, which is my peak values here. I have a value of -1, which is my valley values. Where do you think we would draw on our prime axis? 5. So I'm going to draw in my prime axis at a value of 5. So when I'm dealing with my graph, it's going to go up and down. Remember what our prime axis is. Our prime axis is what we go up from and we go down from. Whoops. He says a value of 2. Now, if that would be our prime axis, is that something we go up from and we go down from? We all said about. Now we need to make sure though, when we go up and down, what has to be true about going to our peaks and going to our valleys? Has to be the same. Has to be the same distance to my peak and to my valley. It needs to cut the graph in half. You want to think of it that way. So we can draw in our theta prime axis at a value of 2, which tells me I have amplitude, period, vertical phase shift, horizontal phase shift. The prime axis is our what? Vertical phase shift. So our vertical phase shift is a value of 2. Now the next thing is the easiest thing that falls out from throwing in the prime axis. And to tell you what would be the next thing we'd be able to find, that's where we draw our prime axis. We still need to find amplitude, period, and horizontal phase shift. So this is my prime axis. What would be the next easiest thing to be able to find?
Period?
No, not the period.
Amplitude?
Amplitude. Now how would we find the amplitude?
It would be like the top. Isn't it the top one and the top number?
Well, how do we calculate the amplitude? It's the distance from our prime axis to what? It's our prime axis. By definition, what's the amplitude? Distance from the neutral axis to what? Look in your notes. Okay, in mathematics, no matter what we're doing in mathematics, we can always go back to definitions. Okay, definitions tell us what we have to do to be able to solve the problem. That's why it's important to be organized, so I can flip back to my notes and just go back 2 days in my notes and be able to, okay, amplitude, what's it mean to be an amplitude? It's on day 1, very bottom of the page.
The distance from a neutral axis to the peaks and valleys.
Okay, the distance from the neutral axis to the peaks and valleys. So if we take a look at this, here's our neutral axis, here's our peaks, here's our valleys. What's our distance from our peaks and valleys from the neutral axis?
Oh, yeah. I don't know.
Here's my neutral axis. Where's my neutral axis is at what y value? 2. Okay. Where's my peaks?
5.
Where's my valleys? Okay. So what's my distance from my neutral axis to my peaks and my valleys? 3. So we have an amplitude of 3. Okay. Next thing. Need to calculate the period. Okay, by definition, a period was a portion of the graph to another portion of the graph where the graph starts to repeat itself. My suggestion to you is to go from peak to peak or valley to valley. And it doesn't matter, whatever one gives you numbers at the bottom. So if I go from peak to peak or valley to valley, so I'm going to go from here to here. Okay, and you may have to draw some vertical lines down. Okay, I have a vertical line here, vertical line here. That would be peak to peak, valley to valley. What is the degree measure for the period? Okay,
180.
180 degrees. I'm at 30 degrees. This is 210 degrees. So we have a period of 180 degrees. If I went from valley to valley, I have negative 60 here. I have 120 there. So the period would be 180. So from this, we can calculate a B value. Leo, what would be our B value if the period's 180? Well, how do we calculate the period? How do we calculate the period? How do we calculate it? How did you calculate in every one of the problems that you did for today? This is what's also important by what I do at the beginning of my class. Okay, I don't talk about all this stuff at the beginning of class just to hear myself talk. Okay, I talked about this stuff at the beginning of class, so reviews all the ideas that we have. So it may be in your best interest to write the things down. If you don't want to write the things down, okay, that means I'm gonna memorize this and I'm gonna have it in my memory. Well, if you don't have it in your memories, you're gonna struggle in this class because when I start asking questions, you're not gonna know what the answer is. How do we calculate it? Take our 360 and divide it by our B value. Well, the period is 180 degrees. I want to find the B value. Well, if I multiply by B and divide by P, my B value is also this 360 divided by the period. Well, the period's 180 degrees, so what's our B value then? Leah? 2. So we got 3 of the 4 tidbits of information. Now we have to find the 4th one. Okay, we have to find the 4th one. The 4th one is our horizontal phase shift. Well, what we talked about here, our horizontal phase shift is our theta start value. So you have to find the theta start value you want to work with. Here's my suggestion for you. Just a suggestion. It's not always going to work. Okay? But the majority of the time it will work and you'll be able to get an equation down. The easiest one to work with here is when I start at a peak. When I start at a peak, what trig function do we have? And is it positive or negative when I start at a peak? Zoe, what trig function are we dealing with if I start at a peak? Cosine. Is it positive or negative? Positive. It's a positive cosine. So find a peak. Find a peak. And there's our horizontal phase shift of 30 degrees. When I'm at a peak, this gives us a positive cosine. So now I could just fill in my numbers to my equation. Have y is equal to vertical phase shift, which is a value of 2, plus our amplitude, 3. Sine or cosine, well, we went to a peak, so that is a positive cosine. Our B value, which is a value of 2, theta minus our horizontal phase shift. Well, suppose you said, I wanted to use 210. Well, that's at a peak too. Why can't we use that? Well, you can. That is a correct solution. Suppose you want to be adventurous and you said, well, I want to use this negative 60. Now we are at a valley. So if we're at a valley, what do we have to use? Negative cosine. So I can write an equation, y equals 2 minus 3 cosine 2 theta minus a negative 60 or theta plus 60. That's a correct equation. Maybe you want to use 120. Then this would be theta minus 120. That's a correct equation. If you want to play some games of halves, I'm at negative 60 here. I'm at 30 here. My halfway point between negative 60 and 30 is negative 15. But now I'm starting on my neutral axis and climbing the hill. So that would be a what? Positive sign. So y is equal to 2 plus 3 sine of, oops, 2 theta plus 15. That is a correct solution. What we have here is we have an infinite number of correct solutions. And either one would be, once again, if you would have put any of those 4 down or 5 down, I would count it correctly under test. But you need to show me this right here. All right, negative 1, 1, 2, and 3. All right, draw in your prime axis. Where would your prime axis go? I peak out at negative 1, I valley out at 3. Draw in your prime axis. Okay, and once again, you're trying to find 4 tidbits of information, or 5 really. You have amplitude, period, vertical, horizontal phase shift. Okay, so you still are dealing with the same values that you worked with before. Okay, drawing your prime axis, what piece of information does that give you? Okay, put it down. From there, what's your amplitude? What is your amplitude? What's your distance to your peaks and valleys? Then go from peak to peak or valley to valley, calculate the period and your B value. Then find a starting spot that you would like to use. Once again, my suggestion is go to a closest peak, but sometimes I vary from that when I have something that's a little bit easier to work with. But if you always go to the closest peak and use that as your horizontal phase shift, that will give you a positive cosine curve every time. So you don't have to worry about sine or cosine. If you go to a peak, that's a positive cosine curve, and you can always embed that in your brain. You can always utilize that. Write your equation, and then compare your answer to somebody around you.
Yeah, just
And if you have a different horizontal phase shift, just discuss it.
Like it's 9.
But it's obviously we should use that.
I feel like you tell me what you did. Oh, you did.
Okay, take a look. Vertical phase shift, the least what do you have? Vertical phase shift. -1. Amplitude then comes down to what, Judah?
2.
2. Period. What do you get for the period, Ian?
90.
90, which means our B value is what?
4.
Okay, your B value is 4. So all those things should be the same for everybody here. Okay, those 4 things should all be the same. Now it depends on what you did with regards to your graph here, your horizontal phase shift. Where do you want to start at? Okay, Justin, where'd you start at?
30.
At 30 degrees. So he went, let's see, that's 90. We're at 90, 90, so this is 45 at a peak, halfway between 45 and 0. Did you use positive sine or cosine?
I did sine.
You did sine.
Sine it.
Okay, so if you play your games of halves, this is what, I mean, you're at 90 here and you're at 0 here. So my peak is going to be at 45. So my gains of halves between 45 and 0 would be what? What would be this value be? 22.5. So if you use this positive sign, you would have to use 22.5. So then you would have y is equal to what then, if you use 22.5?
Equal to 1 plus 2 sine 4, and then theta minus 22.5.
Okay, can I say a negative with the 1 there? Because a vertical phase shift would be a negative, that should be a positive, that should be a negative. Okay, if we use that, that is fine. Ethan, what vertical phase, horizontal phase shift did you use?
I used 90.
You used 90, all right? So you came out to here. What equation did you write?
I wrote -1 minus 2 cosine 4 and theta plus 90.
Did you use, which 90 did you use? Negative or positive?
Oh, positive.
So that would be theta minus 90 if you use positive 90. If you use this 90 over here, it actually all comes out to wash for you. That would work too. Yeah, plus or minus 90. Anybody use the horizontal phase shift of 0? Is 0? The nice thing about 0 is you're at a valley, so you have y is equal to -1 minus 2 cosine of just 4 theta. And you're at a valley here. You don't have theta minus or plus anything because you have theta minus 0, which is just theta. So you have that there also that you can utilize. All right, let's go to the back side. Well, again, find your amplitude, period, vertical phase shift, horizontal phase shift, and your B value. Find those tidbits of information, check your answers, then write yourself an equation. All right, Lee, what'd you get for your vertical phase shift or your prime axis? 0, it's correct. Because we peak out at 2, we bottom out at -2. So we have a prime axis at our value 0, which means our amplitude is going to be what, Natalia?
2.
2. So our peak and our valley, we go up and down 2. Period. What do you get for the period, Lily? 720. We go from -180 to positive 540. That's 720. Or we can go from 0 to 720 here. B value comes out to what, Lily? 1/2. And then horizontal phase shift. What do you use for your horizontal phase shift, Judah? 0. So if you use 0 for horizontal phase shift, what do you write for your equation?
-2 sine of 1/2 theta.
Sort of cleans it up a little bit, even though it's not a cosine curve, it's going down, so it's a negative sign there. But if you use -180, that would be fine. 540, that would be fine. Y is equal to -2 sine. Y is equal to 2 cosine of 1/2 theta plus 180. Theta minus 540. Those would be also correct too. You could use either one of those to go to your peak, your 2 peaks here. If you want to negative 180, you have negative out here, then cosine 1/2 theta minus 180. That is fine too. Once again, infinite number of solutions here. Infinite number of solutions. Okay, homework is on page 54. You have problems 9 to 17. With that, you're just doing what we just did here. They give you a graph. They even throw in the prime axis for you most of the time. Find the amplitude, period, vertical, horizontal phase shift, and write yourself down the equation. Tomorrow, I will not be here, so you'll have a worksheet that will basically be everything that we've been doing. Solutions will be provided for you, so you'll be sitting and working on the worksheet tomorrow. Questions? As done.